We're going to start the next chapter of our book about hypothesis testing. But before that, let's review what we have learned so far. So we deal with populations like this one. Then we collect a sample. From the sample, we were able to compute some statistics like the mean, standard deviation, or proportion. And then we use that information to create confidence intervals. So these confidence intervals were created to learn about the population, because remember, we don't know anything about the population most of the time. So we use a sample to learn about the population. So we can learn, for example, about the mean of the population by computing a confidence interval. So in other words, we need a lower limit for the mean and upper limit for the mean, and we're going to use the mean of the sample as part of that those computations. The same thing, if we want to know about the standard deviation of the population, then we need to find a lower limit and an upper limit for that standard deviation, and the same thing for the proportion of the population. So, and this is something that we cover in chapter 8. So that's one of the purposes of collecting samples. Another purpose of collecting a sample is for testing. So testing is done just when you want to know about that sample being extracted from a certain population. So you want to know whether the sample belongs to a given population or maybe belongs to a different population. So if you just work with one sample, that's something that we're going to cover in chapter 9. Just one sample versus the population. Or maybe you collect two samples and you want to know whether those two samples belong to the same population, or maybe one belongs to a different population. So this is something that we're going to cover in chapter 11. Finally, we might want to know about 3 or more samples, the same thing. To know if those 3 samples belong to the same population, or maybe one of those belongs to a different population. So what is the main application of doing this kind of testing? So these applications are very useful when you are testing treatments. So but let's say that you are trying to know whether a vaccine is useful to cure an illness or not. So you're gonna have two possible answers for that question. Maybe there are no effects. So in other words, your sample belongs to the original population, the original of the population that might be composed of the people having that illness. Or maybe there are some effects, so you are creating a new population. So your sample is coming from a different population where the main parameter is different from the parameter of the original population. So this is just an overview. We're going to go deep in all these concepts and ideas and procedures in this chapter and in the other two chapters, chapter 11 and chapter 14. So what are the steps to solve problems like this? So first, we're going to need to read very carefully. We're going to read carefully the problem uh, because we want to know uh, what the claim is. So we're going to find the claim. Then we're going to express the claim. We're going to express the claim and also the null hypothesis, the alternative hypothesis symbolically. So symbolically, we're going to learn about the null and the alternative hypothesis in a minute. So later we're going to determine the significance level alpha, the type of test that we're going to conduct, and also the sampling distribution that we need to use. You are familiar with sampling distributions now. You know that if you want to know something about the mean, you use a sampling distribution. If you want to know something about the standard deviation, you use a different sampling distribution. If you want to know about the proportion, then you have the corresponding sampling distribution. So once you have this, you're gonna compute the sample statistic. So the sample statistic is just the number, the value that you're gonna use to do all your testing, which is the next step. So you're gonna conduct the test. So you're gonna conduct the test, and you're gonna make a decision. So you're gonna make a decision, and to do the decision, to make that decision, to make a decision, there are gonna be two possible methods to do that. There is one method that we call the critical value method, or we're gonna use another one which is the p-value method. So we're gonna learn about this. I'm just giving you an overview of what is the next things that we're gonna learn. Finally, you need to write a conclusion. You need to write a conclusion in terms of the null hypothesis and also in terms of the claim, because at the end of the day, this is what people are interested in. So they want to know about claims regarding populations. So this is an overview, as I mentioned before. This is just it's a big picture of what we're gonna do now. So our chapter 9 then is about hypothesis testing. So I'm going to write this now in your notes. So I'm going to do the same thing. I'm going to give you now an overview of chapter 9 only. So chapter 9 is about hypothesis testing. So we have hypothesis testing. So that's the title of the chapter. This is on page 415 in your book, and I'm going to add, this is just with one sample. Remember, we're going to do testing with two samples, so that's in chapter 11, or we're going to do testing with 3 or more samples, which is covered in chapter 14. So what we're going to do now, this chapter. In this chapter, we're going to work with one sample only. So again, we're going to start with a population. We're going to collect a sample, and the things that we're going to do is first, we're going to setting up the problem. So we're going to set up the problem. So by doing what we're going to do is we're going to write the claim. We're going to write the claims about the mean or the standard deviation or the proportion. Remember, proportion is just successes over a number of trials. So, and then we're going to write the null and the alternative hypothesis, and everything is going to be written in a symbolic way. In a symbolic form. So what is the meaning of that? So for the null, you need to write an equation. For the alternative, you need to write an inequality. An inequality for the alternative. And I'm going to give you the steps to do that. But the important thing is that if you know the alternative is going to help you find the kind of test that you're going to work on. So the next step is just finding or determining the type of test that you're going to work on. So there are 3 possible scenarios. So in one case, we're going to have what we call the right tail test, which is basically when the alternative is written in the following way. We have a parameter greater than a value. So when you have this kind of inequality, for your alternative hypothesis, then you are dealing with a right tail test. The other possibility is if you have your inequality written in the following way, that you have a parameter less than a value, then this is a left tail test. And this is important because depending on what kind of test you are working on, then there is going to be a difference in the computation that you're going to perform, either by using tables, using your Texas instrument, or using language R. So the third possible scenario is when you have your parameter and the inequality indicates that your parameter is just different than a given value. So in that case, you're going to deal to what we call a two-tail test. A two-tail test. So that's the second step. We want to know what kind of test we're going to perform. So these guidelines that I'm giving you are going to be useful also for chapter 11 and also to understand chapter 14. So once you know the type of test, then you're going to proceed with the next step, which is just you need to determine the sampling distribution that you're going to use. You know, from confidence intervals before, we learned that there are different kinds of sampling distribution depending on what is the parameter that you're going to use. What is this parameter? So, for example, let's write here, if our parameter, the one that we are testing, is the mean, then we're going to use the normal distribution. We're going to use the normal distribution if, and this is important, the standard deviation of the population is known. If you don't know the standard deviation of the population, which is the most common scenario, then you're going to use the student t distribution. So you're going to use this one when the standard distribution is unknown. If the parameter of interest is the proportion, then we're going to use the standard normal distribution. And finally, if you want to know about the variance of the standard deviation, in this case, I'm writing the standard deviation, then we're going to use the chi-square distribution. So you are already familiar with these distributions, so I don't think there is going to be a problem just to just understanding what we're going to do next. So the next step, you know, now you set your null hypothesis, your alternative. With the alternative, you find about the type of test that you're going to perform. Then from the parameter that you're going to test, you find the sampling distribution that you're going to use. And now the next step is just doing the computations. So the next step is working the computation. So we're going to have now step number 4 is going to be you're going to compute the test statistic from the sample. So it's the sample statistics, and that's the one that you're going to use to make your decisions. So again, I'm going to repeat many things, and this is good for you because if you're working on the mean, then and you know that the standard deviation of the population is known, your test statistic is going to be just the mean of the sample. So, and also the sampling distribution, remember, I'm going to include this column again just for you to remember. The sampling distribution is the normal distribution. The other option is when the standard deviation of the population is not known. So now you're gonna use t, and I'm going to include the formula for you. You use x bar minus mu over the standard deviation of the sampling distribution, which is the standard deviation of the sample over the size of the sample. And again, the sampling distribution that we're going to use is the distribution. This is when you are trying to know, or when you are performing a test involving the mean. If you are performing a test involving proportions, so you just need to use z. We're going to use the standard normal distribution, and the formula for z is very similar to the formula for t. Then if you want to know about the standard deviation and a testing that involves the standard deviation sigma, then you're going to use your test statistic is going to be chi-square, just n minus 1, and multiplying the standard deviation of the sample over the standard deviation of the population. So these are the different test statistics that we're going to use in this chapter. So then the next step is we're going to make a decision. We're going to make a decision. To make the decision, we have two methods. We're going to have the critical value method, or we're going to use the p-value method. In one case, we're going to use, this is used for computations in R, we're going to use Q functions, and for p-values, we're going to use p functions. So, for example, in this case, if we're working with the mean, we're going to use Q norm if sigma is known, the standard deviation of the population, or we're going to use Qt if sigma, the standard deviation of the population, is not known. For proportions, we're going to use Q norm. I'm going to write parentheses indicating that these are functions that need some input values here. And for standard deviation, we're going to use Q chi-square and also input values. The p functions that we're going to use for the mean are going to be p norm, again, if the standard deviation of the population is known, or we're going to use pt if the standard deviation is not known. And for proportions, we're going to use p norm again, and for the standard deviation, we're going to use p chi-square. So you see it's the same thing every time. This is very similar to the functions. These are very similar to the functions that we use to create confidence intervals in our previous chapters. So later I'm going to give you details about these functions once we start using uh, those functions for our computations to make a decision. And then we're going to see later also how to write the conclusion. So now we're going to start with the first section of this chapter, just to show some terminology that we're going to learn dealing with hypothesis testing. So we have now section 9.1. So we already covered a lot of information that we're going to need to solve these problems where we need to do some testing. So either with one sample, which is chapter 9, two samples, which is chapter 11, or three or more samples, which is chapter 14. So let's start with the first section. Section 9.1 is on page 416. These are just basic principles of hypothesis testing. We're going to start now defining the null hypothesis, H naught. So I'm going to write just the null hypothesis. I'm going to copy just from your book about a parameter states that the parameter is equal to a specific value. For example, we might have a null hypothesis that says that the mean is equal to 35. Okay, that might be just the way. So it's always an equation. Okay, it is always an equation. In other words, it only contains the equal sign for the null hypothesis. Now, the alternative hypothesis or alternate hypothesis is H1. So it says that the alternative hypothesis about a parameter. Everything is about parameters. About a parameter states that the value of the parameter differs from the value specified by the null hypothesis. So in which ways you can say that, for example, that the mean is less than 35. Or you can say that the mean is greater than 35. Or you can say that the mean is different than 35. So it is always an inequality. It is always an inequality. So you don't see the equal sign here embedded. So you cannot have greater than or equal to 35. It has to be a strict inequality. strict inequalities. No equal sign is involved in the expression. So I'm writing this because this is very, very important. So, and also you can see here in your book on page 417 that we're going to have three kinds of tests depending on that inequality. So a left tail alternate hypothesis states that the parameter is less than the value specified by the null hypothesis. So when you have a parameter less than a value, is always a left tail test. On the other hand, you might have the parameter greater than a value, that is going to be a right tail test. And finally, you might have also that the parameter is just different than a given value. So you don't know, or you don't have any idea whether the value is going to be greater or less than. You only know, or you are trying only to test that the value is different than a given value, in this case 35. So when you have this inequality symbol, then this is a two-tailed alternate hypothesis. And as I mentioned before, depending on the test that you're going to perform, then it's going to be a subtle, slightly different formula that we're going to use to conduct our test. Finally, from this section, the only thing that you need to have in mind that is important is about type 1 and type 2 errors. This is just a definition that you're going to learn. So you're going to make a decision at the end of the test. And your decision is going to be rejecting the null or not rejecting the null. So check this very carefully. You don't see here the word accept. So we don't test about accepting the null. We reject or we don't reject the null. Now, if the null is true, then and we reject it, then we are committing type 1 error. If the null is false and we reject it, we did the right thing. So it was a correct decision. On the other hand, if the null is true, but we don't reject the null, then we are making the right decision. And if the null is false and we don't reject it, the null, then we are committing type 2 error. So there are going to be some probability values associated with these types of errors that you're going to learn in a more advanced courses. This is the only thing that you need to learn about. Rejecting the null, you commit a type 1 error if the null was true. You don't reject the null, then you commit a type 2 error if the null was false. So that's section 9.1. Now we're going to start section 9.2. So let's start with section 9.2 and we're going to start solving problems. So we're going to apply all the methodology that we just mentioned a moment ago at the start of this lecture. So we have section 9.2 on page 421, and we're going to start with the first testing. This is going to be about hypothesis tests for a population mean. For a population mean, and where the standard deviation is no. So this is going to be the first problem that we're going to solve, the first kind of problem. And now you're going to see the different methods, the critical value method and the p-value method. So let's see. So we're going to start with, let me see, we're going to continue in a minute. So in section 9.2, we're going to conduct tests for population means when the standard deviation is known. So your book shows some steps that you're going to follow depending on whether you want to use the critical value method or the p-value method. So if you want to use the critical value method, then you need to check your book on page 425, and you're gonna see this blue box where you can read that the 5 steps. So the first step is just writing your claim, your null, and your alternative hypothesis by using either inequalities or the equation for the null. So you have here always an equation for the null and the alternative by using an inequality. So, and depending on this, remember you're gonna be able to identify the type of test that you're gonna perform. Then you need to choose a significance level alpha, and if you're using the critical value method, you need to find the critical values. So to find the critical values, you can use tables in the appendix of the book. You can use the Texas Instrument calculator, or you can use language R, as I'm going to show you in a minute. So the next step, you're going to compute the test statistic, which is just transforming the information from the sample in a numerical value that we're going to use to make our decision. So in this case, when you are testing a population mean width, sigma known, so you can see here, population mean width sigma known, then we're going to use the z-score and the standard normal distribution. So you need to compute then the z-score. It's going to be just the mean minus the mean of the sample minus the mean from the null hypothesis over the standard deviation from the population over the square root of n. Then the next step is just making a decision. It's going to depend on the value that we found, z, to know whether this value is inside of the region that favors the null or is outside of the region that favors the null. I'm going to show you with a diagram later because this is just using different conditions. If you have a left tail test, that's the condition that you need to satisfy to reject the null. And finally, we're going to state the conclusion in a written by writing a sentence. So these are the 5 steps when you are using the critical value method. Also, if you check page 431, you're going to find the steps to conduct the same kind of test, but using the p-value method to make your final decision. So the first steps are the same. So again, you set up your problem by writing the null as an equation, the alternative as an inequality. Then you need to choose a significant level. Most of the time, the significant level is given. If the significant level is not given, we're going to use always alpha equals 0.05. Then you're going to compute again the test statistic that you're going to use to make your decision. And in this case, given that test statistic, you're going to compute different values of probability that depend on the kind of alternative, the alternative hypothesis. So if you have a left tail test, you're going to find the p-value by computing this area under the curve. If you have a right tail test, you're going to use this diagram and compute the area under the curve again, the right tail test. Or if you have a two tail test, you're going to compute these two areas and you're going to add them up to get your p-value. Then we're going to interpret the p-value. This is the easiest method because interpreting the p-value is very easy. You just need to know that if the p-value is very, very small, the null must go. So if the p-value is less than or equal than alpha, then you reject the null. So I'm going to give you these two procedures in one procedure only to simplify our life. So I prepare uh, these notes for you that summarizes the two methods in one single page of piece of paper. So again, we're going to start expressing our claim, the null and the alternative symbolically. Then we're going to determine alpha by reading carefully the problem, or If there is no information given, then alpha is going to be equal to 0.05. Then we're going to determine the type of test and the sampling distribution. The type of test is based on the alternative, and the sampling distribution is based on the parameter that you are testing. In this case, if you are testing the mean, then you're going to need to use the corresponding sampling distribution. Then I have here the step for you to compute the critical values from the given alpha, and I'm just writing here an asterisk because it's either this step or the other step. So you either compute critical values or compute p-values. So let's see. If you need to compute critical values, you just need to check the kind of testing that you are performing. If you have the alternative as written as the parameter greater than a value, again, this is a right tail test. So you're going to compute this critical value, which is the value of z in this diagram, this value of z based on alpha. So alpha is the area. So this z alpha is going to be computed by using q norm of 1 minus alpha. So this is very simple. This is the command in R that we're going to use to compute this critical value. Then if your parameter is less than a value in the alternative hypothesis, then you have a left tail test. So this is a left tail test. Then you're going to compute this value here, this z alpha based on this area alpha, and we're going to use just q norm of alpha. So it's very similar to the previous one. If you are in the upper portion of the curve, you have to write 1 minus alpha. If you are in the lower portion of the curve, you just write alpha. And if you have your alternative written as a inequality, the parameter different than the value, then you're going to split your alpha in two parts. So you're going to get alpha over 2 for the upper part, alpha over 2 for the lower part. So now you need two critical values. You're going to get a lower critical value, z alpha, is going to be just q norm of alpha over 2. And you're going to need an upper z alpha over 2, which is going to be just q norm of 1 minus alpha over 2. So all the time, upper values are 1 minus the area. Alpha over 2 is the area. Alpha is the area in this case. Or if you are computing the lower critical value, is just q norm of the area. In this case, the area is alpha over 2. So this is a two-tail test. Then this is a step that you're going to need to compute in both cases. If you're using critical values, you need your test statistic. If you're using p-values, you need your test statistic. So this is something that you need to do in any case. So you're going to compute your test statistic. That's the value from the sample. And in this case, we're going to use the z-score. And you remember the definition. The definition of z-score in this case is just the mean from the sample minus the mean that is indicated in the null hypothesis. I'm going to write this note here, this 0. Then you're going to divide this by the standard deviation of the population because it's a value that is known over the square root of n. If you're going to use R, I'm just writing here the steps that you need to write to get your z-score. You just use parentheses for the numerator, parentheses for the denominator, and that way you're going to prevent many mistakes. If you are in the case that you want to know the p-value, then that's the step that you need to perform instead of step 3. So there are again 3 ways because most of the time we have 3 cases for the alternative. So either you have the parameter greater than a value, then the p-value, which is this area, is going to be based on the statistics that you computed from the previous step. So that p-value is going to be just 1 minus p norm of z. If you have the left tail test, so the parameter less than a value, then this area is our p-value, and it's going to be just p norm of z. And finally, if you have the alternative written as the parameter different than a value, then you're going to compute the p-value in any of these two ways. It depends on this score that you found here. If this z-score is positive, you use this formula. If the z-score is negative, you use this formula. So if the z-score again is positive, you just compute 2 times parentheses 1 minus p norm of z, close parentheses twice. And if the z-score is negative, then you're going to need to multiply p norm of z by 2. So those are the steps that you need to perform before making a decision. So making the decision is the last step. So how do you make the decision? If you are working with critical values, so the critical value method, then you just need to check you have your critical values somewhere. So maybe you have a critical value here, you have another critical value here. So this is z alpha over 2, z alpha over 2. These are your critical values. So this area is in favor of the null. So this is the region for you to not reject the null. If your values for your test statistics end up in this area, this is the region, the critical region that's in favor of the alternative. So you're going to check if the test statistic is outside of the region in favor of the null, then you're going to say reject the null. So to reject the null, you expect your z that you're going to compute to be either here or here. If you are using the p-value method, then the thing is very simple. You're just going to compare your p-value with alpha. If your p-value is less than alpha, you reject the null. So you don't need to do any diagram. So let's start solving exercises to use these two methods. I'm going to solve one problem using the critical value method and another problem using the p-value method. So we're going to start with example 9.8. This is on page 425. So let's read the problem, and then we're going to start working on all the steps one by one for you to understand. And then once you understand these two exercises today, everything is going to be the same. Everything, regardless whether you are testing means, proportions, standard deviations, 2 samples, 3 samples, is always the same. You're going to follow the same steps. The only thing that you're going to change in one cases are going to be the sampling distributions, and in other cases the statistics that you're going to compute to make your decision. Maybe you just need to change alpha. So you need to read very carefully your problem. So let's read example 9.8. So it says that the American Automobile Association reported that the mean price of a gallon of regular grade gasoline in the city of Los Angeles in January 2017 was $2.82. A recently taken simple random sample of 50 gas stations in Los Angeles had an average price of $2.77 for a gallon of regular grade gasoline. Assume that the standard deviation of prices is $0.15. An economist is interested in determining whether the mean price for all Los Angeles gas stations is less than $2.82. In this case, you're going to use the critical value method to perform a hypothesis test at the alpha equals 0.05 level of significance. So that's our problem. So let's start writing or finding the claim. That's the first step. So you need to find a sentence where you want to see the person conducting the survey, what is the interest of that person. In this case, you can read here, an economist is interested in determining whether the mean price for all Los Angeles gas stations is less than 2.82. So that's the claim. So this researcher, this economist, is claiming that the gasoline price in Los Angeles is less than $2.82. So let's write that down, and we're going to start now solving our problem. So let's see. So from this problem, we're going to start with our first step, which is just writing the claim. So the claim, again, if you read carefully the problem, is the sentence that says an economist is interested in the mean price of the gasoline is less than $2.82. So that's the claim, but we need to write the claim by using symbols. So in this case, we are talking about the mean price. So that's the mean of the population, and in this case, we said that this mean is, or should be, or they are trying to find out that the mean is less than 2.82. Then one way to determine the null and the alternative is just writing the opposite of the claim. So what is the opposite of the claim? So the opposite of the claim is going to be just mu. Instead of less than, you're going to write greater than or equal than 2.82. So the opposite contains the opposite symbol for the inequality and the equality. So it's the complement. So this is another to say that the opposite of the claim is the complement. The complement of the claim. Now you have two expressions. So you're gonna find which expression is the alternative. So which one is H1? So H1 is going to be the expression that doesn't contain the equal sign. So look for the expression not containing the equal sign, and that expression is going to be your alternative. So in this case, mu less than 2.82 is my alternative. Then you just write the null. The null is always an equation, so the null is going to be mu. You write the parameter, you write the number, and you write the equal sign. So the null is always an equation. So it contains the equal sign. It doesn't contain any inequality symbols. So this is the first step. So usually in your book, you're going to see the null written first and the alternative written after. It doesn't matter the order, as long as you know that you're writing the null and the alternative in the proper way. So now we're gonna use the alternative. So the alternative most of the time is the most important expression, because based on the alternative, you're gonna determine many things. First, the type of test. So you're gonna determine the type of test. So you can see that the alternative, it says mu less than 2.82. So that means that this is a left tail. We're going to need a left tail test to make our decision. So this is a left tail test. Also the parameter is, this is the parameter. the parameter is the mean, then the sampling distribution, that we're going to use, the sampling distribution is going to be just the standard normal distribution, the standard normal distribution, because we know the standard deviation of the population was given in the problem. So the standard deviation was given is 0.15. So the standard deviation is 0.15. So that's the reason for us to use the standard normal distribution, because this standard population of the standard deviation of the population is given for this problem. So that's our third step. Now the next step is just getting the critical values. So we're gonna write now the critical values. We're gonna find them. So we're gonna write here so we have step 4. So critical values. So maybe the ordering is different from the one that I gave you before, but you just need to check the steps that you are performing. So critical values. So in this case, we have a left tail test. So we need alpha. Alpha is given is 0.05. That's the significance level. Significance level. So this value is given. Just read again the problem. So alpha, this is a left tail test. Left tail test because of the alternative hypothesis. So this is going to be my alpha equals 0.05. So I need to find this critical value. It's critical because this is the one that we're going to use to determine whether our sample is inside of this region or outside of this region. So this is going to be the region in favor of the null. This is going to be the region in favor of the alternative. So there are only two regions in this case because it's a one-tail test. So a left tail test is a one-tail test. So that means that there are only two regions, one in favor of the null, one in favor of the alternative. So we can check our notes, and you can see that the formula that we're going to use to find the value for this critical value is going to be by using Q norm of alpha. So we're going to use R to find Q norm of alpha 0.05. So let's start our work with R. So let's open our program and share the screen now. So we have R here. We're going to change the font size for you to see the computations. So and we're going to write just Q norm of 0.05. That's what we need to compute. And this is going to be just negative 1.64454. So that's the critical value. So let's go back to our notes. So we have here now the critical value. alpha. So now we know this value. So the next step is you just need to compute the test statistic now. We're gonna compute the test statistic. So from the sample. So we're gonna use Z, the mean minus the mean from the null hypothesis over sigma over the square root of n. So what are these values? These values were given. The mean that they found in the sample was 2.77, and they conducted a survey with a simple random sample of 50 gas stations in Los Angeles. So let's find then the z-score for this sample. Parentheses 2.77 minus the mean from the null is 2.82. We're going to divide this by the standard deviation of the population, which is 0.15. Because we are working with a sampling distribution, we need to divide this by the square root of the sample size, which is 50. So let's do these computations by using R again. So let's go and move to our R console. So we have parentheses 2.77 minus 2.82. We divide by 0.15 over the square root of 50. My value of the z-score for my sample is negative 2.357023. So let's go back to our notes. So now it's time for us to do the decision. We're gonna make a decision now. So to make a decision, we're gonna use the statistic that we found, and we're gonna use the critical value. So we have a left tail test. So we have here our critical value is the threshold, negative 1.64488. So that's the critical value. So that's the border or the boundary. This is the boundary between the null region and the alternative region to make our decision. So this is the null region and this is the alternative region. So now we're going to use this value that we found here, this z. Where is this value? Are going to be plotted. So negative 235 is going to be somewhere over here. This is our z equals negative 235. Okay, so now you know that this value is not in favor of the null. So we're going to reject the null. So we're going to write now a sentence to say that. This is going to be just a conventional way to write things. So we're going to write the conclusion. We're going to state the conclusion. So usually we start with writing a conclusion in terms of the null. So we're going to say that there is enough evidence. There is enough evidence to reject the null hypothesis. Okay. Now, this is not the question. We need to talk about the claim. The claim that the researcher, that the economist was talking about. So, in this case, we need to compare first the claim and the null. So, you need to go back to our setting. So, we have here our setting. This is the claim, and this is the null. You can see the claim is mu less than 2.82. You can see the null mu equals 2.82. So you can see that the claim and the null are different. When they are different, you need to change this verb and this subject. So when they are the same, you don't change the verb, you only change the subject. So in this case, we're going to write there is enough evidence to, and then we're going to switch the verb. Instead of reject, we're going to write to accept. So there is enough evidence to accept the, instead of writing the null, now we're going to write the word, the claim that, and then you rewrite the claim, or you rephrase the claim. There is enough evidence to accept the claim that the mean of the price of the gasoline in Los Angeles is less than $2.82. So you just rewrite the claim or rephrase the claim. The important part here is the verbs that you're gonna use. The only verbs that you're gonna use in your final answer is reject or accept when you are talking about the claim, because remember, you cannot write that you're gonna accept the null. Never. You never accept the null. You reject or don't reject the null. But for the final answer, this is what we need, and this is what you need to give me in the final exam. So that's one problem using the critical value method. I'm going to work now another problem using the p-value method, and then I'm going to give you problems for you to solve and send me your solutions by email or by using Canvas in this case, because now we have we have the way to submit our problem solution by using Canvas. So let's work another problem. And now in this problem, we're gonna use the p-value method. I prefer the p-value method, but it's up to you. You can. The important thing is that you need to learn about the two methods, but you can choose the one that you prefer the most. So now I'm going to work on example 9.13 on page 431. So let's look for that problem. So let's see page 431. So we have here the problem. So let's read this problem. So the problem says that the National Health and Nutrition Examination Surveys are designed to assess the health and nutrition status of adults and children in the United States. According to a recent survey, the mean height of adult men in the United States is 69.7 inches, with a standard deviation of 3 inches. A sociologist believes that taller men might be more likely to be promoted to positions of leadership, so the mean height mu of male business executives might be greater than the mean height of the entire male population. A simple random sample of 100 male business executives has a mean height of 69.9 inches. Assume that the standard deviation of male executive height is sigma equals 3 inches. Can we conclude that the male business executives are taller on the average than the general male population at the significant level alpha equals 0.05? So that's the problem. We have one population of men, and then we are trying to see whether a sample is from the same population or maybe a different population. So let's work on this problem now. So we have to write for our notes first the claim. So let's start with the claim. So the claim is that the mean of heights is going to be greater than 69.7. So male business executive positions are taller than 69.7 inches. So that's the claim. What is the opposite of this claim? Is just mu less than or equal than 69.7. Then what is the alternative? So which one of these two doesn't contain the equal sign? So you can see that the alternative aligns with the claim. So we're going to have just 69.7 here. So the mean greater than 69.7. What is the null? The null is always the parameter, the given number, and also the equal sign here. So from here, you see that we have a right tail test now. A right tail test. So it's going to be something like this. The right tail test. For the information, because we know the standard deviation of the population, 3 inches. So that means that our sampling distribution is going to be the standard normal distribution. So that's the first step. The second step is just going to be the test statistic. We're going to compute the test statistic. So our test statistic is going to be z equals x bar minus mu from the null over sigma over the square root of n, square root of n. So in this case, it's going to be just x bar is it was given. So let's copy that information from the sample. So my sample it was one with the mean equals 69.9 and the sample size 100. So I'm going to write here 69.9 minus the mean of the population 69.7. I'm going to divide this by the standard deviation of the population 3 over the square root of the sample size. So that is going to be for me to find the test statistics. So let's go and check now our console. So we're going to write parentheses 69.9 minus 69.7 over 3 over the square root of 100. So we found that our value for the z-score is going to be 0.6666. So it's just 2/3. So with that information, now we're going to continue with our notes. So we have our test statistics. So now the next steps, we're going to compute the p value. So the p value, you have a right tail test. So you need this value of z is greater than 0. So our p-value, because our value is greater than 0, is going to be just p norm of, it's going to be 1 minus p norm. Let's see. So I'm going to compute. Here is going to be 0.666. So let's find this value. Our p-value is going to be, let's see, our console. So we have 1 minus p norm of 2/3. So it's going to be 0.25. So our value is 0.25, 24,926. So now we're going to be able to make a decision. We have a p-value. So to make a decision, we only need to compare our p-value with our significance level. So alpha is 0.05. So comparing these two, we compare and we find that our p-value is greater than alpha. So when your p-value is greater than alpha, you cannot reject the null. So don't reject the null. So we're going to write our conclusion now. Our conclusion, I'm going to write it in the next page. So our conclusion is that there is not enough evidence. There is not. Now we will have a different answer. There is not enough evidence to reject the null. And now we're going to check our null and our claim. You can see here the claim, you can see here the null, they are different again. So the claim and the null are different, so that means that we're going to write the same sentence with some changes. So there is not enough evidence, and again we're going to change only the verb to accept the claim. So we change the verb, we change the subject, that, and then you can just rephrase the claim that they gave you. That the male business executives are taller on the average than the general male population. So that's the answer for this problem. So now I think it's time for you to practice the method of the critical value method and the p-value method. So let's see. You're gonna one more problem, I think, before. Let's work one more problem. We have example 9.14 because I'm going to show you how to deal with the two-tail test. So this is on page 432. So let's see. That's 9.14. So let's read the problem. Okay, the problem says that a large company, at a large company, the attitudes of workers are regularly measured with a standardized test. The scores on the test range from 0 to 100, with higher scores indicating greater satisfaction with their jobs. The mean score overall of the company's employees was 74, with a standard deviation of sigma equals 8. Some time ago, the company adopted a policy of telecommuting. Under this policy, workers could spend 1 day per week working from home. After the policy had been in place for some time, a random sample of 80 workers was given the test to determine whether their mean level of satisfaction had changed since the policy was put into effect. The sample mean was 76. Assume that the standard deviation is still sigma equals 8. Can we conclude that the mean level of satisfaction is different since the policy changed at the alpha level of 0.05? So now they are not talking about greater than or equal or less than. They are talking about different only. So the mean level of satisfaction is different. So there is no idea about getting a higher value or a lower value. It's just different. So let's work on this problem. So for this problem, we just need to write again the claim. The claim is that the mean is just different than 74. So what is the opposite? The opposite is just the mean equals 74. Now the alternative is going to be the one that doesn't contain the equal sign. So this is the one that doesn't contain the equal sign. So the alternative is just the mean different than 74. And the null is always the parameter, the equal sign, and the given value. So this is the null. Now, from the alternative, you can see that this is a two-tailed test. So now we have two values here, two critical values. So from the sample, we found the mean of the sample is 76. The size of the sample is just 80 workers, and also from here you're gonna see that we know the standard deviation of the population, so is 8, and also from the parameter that we are testing, which is sigma, which is mu with sigma known, then we're gonna use the standard normal distribution again. So we only need to compute our test statistic. Our test statistic is just z is the mean minus the mean of the population over sigma over the square root of n. So this is going to be just 76 minus 74. We're going to divide this by the standard deviation 8 over the square root of 80 people. So my z score is going to be computed by using R. So you can use a calculator, a simple calculator to do this computation. I don't have one at hand, so that's the reason I'm using R, because you can use R as a calculator too. So, and the important thing is that you can have a record of what you are doing with R. You can see on your screen, you can check whether you enter a value incorrectly, and sometimes that's difficult to do with a calculator. So my z-score is 2.23, and this is a z-score which is greater than 0. So to compute the p-value, we're gonna be careful. So now to compute the p-value, so we have here our z-score 2.23. So this is these two areas together are going to be my p-value. So the way that you're going to get it is when you have the z-score greater than 0, your p-value is going to be 2 times 1 minus p norm of your z, your test statistic. So in this case is 2 times 1 minus p norm of z, which is 2.23, and the p-value then is going to be, let's see, let's use R again. We're going to write now 2 times parenthesis 1 minus p norm of 223, 60, 68, and we close the parenthesis twice, so we're going to get 0.025, 34, 732. So let's do our comparison with alpha to make a decision. So we're writing here the p-value that we found by using R. Now we have alpha equals 0.05. We compare and find that our p-value is less than alpha, so then we can reject the null. So now we're gonna write the conclusion. So the conclusion is gonna be that there is enough evidence to reject the null, and then we see that the null and the claim are different again. There are going to be times that your null and your claim might be the same, but most of the time it's different. So they are different, so we're going to write there is enough evidence to accept the claim that workers are more satisfied with telecommuting. Workers are more satisfied with telecommuting. So that's the final conclusion. So now you're gonna work on some problems on your own, and you're gonna take screenshots of your work, and you're gonna upload those screenshots. So let me see. I'm gonna work the following process, and after the break, I'm going to work the next section to conclude our class for today. So these are the problems that you're going to work on. So these are from section 9.2, exercise set on page 442. You're going to work problems 52, 54, 59, and 60. 4 problems that you're going to work on. So you need to make decisions, and then you're going to submit your screenshots to me by using the button in the classwork in the corresponding classwork section. So let's see, this is in 442. Let me look for you to see the problems. Okay, 52 and 54. So I'm going to project first 52, then you're gonna see 54 and the others. Okay, 52 is here. I'm going to give you a couple of minutes to look at 52. You may want to take a picture or check your book. Then 54 is here. 54. Okay, now 59 and 60. The only difference between the first two problems and the second two problems is that you're gonna be given data sets for the last two problems, so you need to compute your mean, and your mean essentially is what you're gonna use. So 59 is here. So you're gonna work part A and part C, because part B you need to get a histogram. You know how to get a histogram, and you can use QQ norm and QQ line to determine normality. So in 59, the most important part is that you need to compute the mean of the data set, and you can create a graph by using histogram, or you can check QQ norm and QQ line for part B, and then part C you're gonna work on the test. And problem 60, the same thing. So you have a data set that is given, and again you need to compute your mean from this data set. You need to create for part A maybe a histogram, or maybe just a QQ plot and a QQ line to determine normality. And finally, if you determine that the population is normally distributed, then you can proceed with part B and do your testing. So that's the first part of our class today. I'm going to give you a break, and then we're going to continue with the second part. We're going to start section 9.3 now, which is on page 445, and it's about a hypothesis test for a population mean when the standard deviation is unknown. So I'm going to write first the steps for the problems that we're going to solve from this section in the same way that I did it for the previous section. So we're going to start with expressing the claim, the null, and the alternative hypothesis symbolically as before. The step is the one that we just saw in the previous section. So we're going to determine alpha, the significant level. If alpha is not given, remember alpha is going to be 0.05. Then also we need to know the kind of test that we're going to perform, and also the sampling distribution that we need to use. Then we have compute if we want to use the critical value method. So this is done by using the given alpha value. So there are also 3 possible cases when you have the alternative where the parameter is greater than a value. Then this is a right tail test. So you're gonna find t, because now this time the sampling distribution that we're going to use because of the standard deviation is not known, is going to be the student and t distribution. So this time then we're going to compute values for t. So the t value that we're going to use as a critical value given alpha is going to be obtained by using qt of 1 minus alpha if you are in a right tail test. If you are in a left tail test, which is when you have your parameter less than a value in the alternative, then t alpha is going to be just qt of alpha. Then you might have also that the alternative is written as a parameter different from a value. So in this case, you have a two-tailed test. And for that, you're going to need to compute two critical values. One is going to be the lower t alpha over 2 is going to be obtained by using qt of alpha over 2. And the other one is going to be the upper t alpha over 2, which is going to be just qt of 1 minus alpha over 2. Once you have your critical values, you're going to need the test statistic that you obtain from the sample. So to obtain the test statistic, in this case, is going to be t. It's going to be obtained by using this formula, x bar minus mu from the null over the standard deviation of the sample over the square root of n. So this formula is very similar to the one that we used before for computing the z-scores, but this time we are not using the standard deviation of the population, we are using the standard deviation of the sample. So that's the only difference from the previous computation. So the formula is going to be very similar. So in R, you're going to just type parentheses x bar minus mu, close the parentheses, then divided by, open another parenthesis, you use the standard deviation of the sample S over the square root of n. So then from here you can use this step and the previous one to make a decision if you are working the critical value method. If you are working the p-value method, then you need to continue with the next step. So to compute the p-value, again, there are three possible scenarios. All those cases depend on the alternative. So if you have a parameter greater than a value, again, you have a right tail test. So the p-value is going to be just 1 minus pt of the test statistic that you found in the previous step. If you have the left tail test, you're going to use p-value equals pt of t. And finally, if you have the two-tailed test, you have two possible cases. If the t that you computed from the previous step is greater than 0, then your p-value is going to be this one. Your p-value is going to be obtained with this. If your test is less than 0, if your t is negative, then you're going to use 2 times pt of t. So it's one or the other, depending on whether the value is positive or negative, the value for your test statistic that you found from a previous step. Then you make a decision. To make a decision, it depends on what method you are using. If you are using the critical value method, then you just need to draw a diagram. You're going to need a diagram for this method. You're going to indicate where your lower and your upper critical values are. And then you're going to use your test statistic and you're going to look where this test statistic lies, whether the value for this test statistic lies in this region or outside of this region. If your value is between this interval in this region, then you are in favor of the null. If the value is outside of this region, either here or either here, you're going to be in favor of the alternative. So when the test statistic is outside, then you reject the null. And when you are using the p-value method, the things are easier. So you just need to compare your p-value with alpha. And if the p-value is less than alpha, then you're going to reject the null. So you can just remember this. If the p-value is small, then the null must go. So this is like the thing that we memorize in school, to remember that when the p-value is very small or small, then the null must go. And what is the p-value? I didn't talk about the p-value before, about uh, its meaning. So you can check pages 428 and 429 to read about the p-value. So the p-value is just the probability, assuming that the null is true, of observing a value for the test statistic that is as extreme as or more extreme than the value actually observed. And the smaller the p-value, the stronger the evidence against the null. So it's what I mentioned before. If the p-value is small, then the null must go. So another interpretation is, or another way to say the same thing, is that the p-value is the probability under the assumption that the null is true, that the test statistic takes on a value as extreme as or more extreme than the value actually observed. So the p-value is not the probability that the null hypothesis is true. So this is important. The p-value is just a probability that your sample statistic is extreme, how extreme is, how unusual is, and then by using alpha, you're gonna set a criterion to decide whether it's so extreme that the sample is not from the population that you are thinking of. So let's solve a couple of exercises to conclude this section and to conclude our today's class. So I'm going to work on example 9.16 on page 446. So uh, let's read the problem, and then we're going to proceed to solve it. So we have this problem. So let's see. The problem says the following. So in a recent medical study, 76 subjects were placed on a low-fat diet. After 12 months, their sample mean weight loss was x bar equals 2.2 kilograms, with a sample standard deviation of S equals 6.1 kilograms. Can we conclude that the mean weight loss is greater than 0? You're going to use an alpha equals 0.5. Alpha is the level of significance. So that's the problem. So let's try to solve this problem now. So we're going to need to write again the claim, the null, and the alternative in a symbolic way. So the claim is that the mean weight loss is greater than 0. The opposite of this claim is just going to be mu less than 0 or equal to 0. So which one of these two is going to be our alternative? You can see that the only one that doesn't contain the equal sign is the first one. So we're going to write mu greater than 0, and the null is always the parameter equal to the value that is given. So now, from the alternative, we know that this is a right tail test. We also know that we're going to use a sampling distribution that is going to deal with the mean of the population, and this time we don't know, so we don't know the standard deviation of the population, so this is unknown. So because of this, our sampling distribution is going to be the student t distribution. So now the next step is just computing the critical values, if we want to use the critical value method. So we're going to need to compute the critical values. So the critical values are obtained from alpha, given alpha. So in this case, it's a right tail test. So we're going to have something like this. So this is alpha, and I need to know this T alpha. This T alpha is going to be just Qt, and then we're going to need to use 1 minus alpha, and then degrees of freedom. Don't forget that. So we're going to have degrees of freedom is going to be n minus 1. So we need the information from the sample. So the information is that the size of the sample is 76. The mean that was obtained is 2.2. That's the loss, the weight loss. And then the standard deviation of the weight lost is 6.1. So that's the information from the sample. So our critical value T alpha is going to be Qt of 1 minus alpha. Alpha is also given is 0.05. So we need to write 1 minus 0.05. Degrees of freedom is going to be 76 minus 1. So my T alpha, I need to go and work on R. So let's see. We're going to have now Qt of 1 minus 0.05, comma 76 minus 1, and we're going to obtain 1.6654. So that's the critical value. That is going to be the threshold to decide whether we need to reject or not the null. So that's the critical value. So let's finish this part by using the critical value method. So let's make a decision. So we're going to make a decision by using this information. So we need to compute our test statistic then. So our test statistic is going to be T. So we're going to have T equals x bar minus mu from the null over S over the square root of n. So our test statistic is going to be x bar is 2.2 minus mu from the null is just 0 over S, which is 6.1 over the square root of 76. So we can do these computations, and we're going to find that this T value is going to be 3.144124. If you use your calculator, you can do this. And then the decision is going to depend on the critical value that we found, which is 1.66, and then we're going to use this value to see that this value goes somewhere here. So it is outside of the region that favors the null. So in this case, the conclusion is reject the null. We're going to reject the null because our test statistic is outside of the region that favors the null. So this is the solution by using the critical value method. Now we're going to find the p-value. So we're going to continue with the same problem but using a different method to find the answer. So we have now a p-value. We're going to find the p-value for this problem. So again, we need a test statistic that we found before. So our t is just x bar minus mu over s over the square root of n. I can write this in terms of the values that I'm going to use. So it's 2.2 minus 0. So I'm going to repeat the computation, but this time I'm going to use R instead of my calculator, just for you to see that it's the same thing. So we're going to get 6.1 over the square root of n, which is 76. So let's do these computations. So we have a parenthesis, 2.2 minus 0. We close the parenthesis. We open another parenthesis, 6.1 over the square root of 76. So we found our t equals to 3.144124. So let's write this down in our notes. So and now we're gonna get the p-value. So the p-value, we're gonna use this t here, and we're gonna use this. We're gonna find this area. So our p-value is this area. So it's gonna be just 1 minus pt, or test statistic t, degrees of freedom. So this is going to be 1 minus pt, 3.144124, and we have 76 minus 1 degrees of freedom. So we write this, we type this in to our console. So to get the p-value, so it's going to be 1 minus pt of 3.144124, and 76 minus 1 are my degrees of freedom. So I'm going to get a p-value of 0.0011. So it's a very, very small value, 93604. So that's the p-value. To make a decision, you only need to compare the value to our alpha. So this is the p-value. Now alpha equals 0.05. We compare and we find that our p-value is less than alpha, so then we reject the null. So we got the same conclusion as before, so, and we should, because it doesn't matter the method, at the end the conclusion should be the same. So we write the conclusion. So there is enough evidence to reject the null, and then we check that the null and the claim are different. So then we're gonna write our final answer. There is enough evidence to accept the claim. Sometimes we can use to support the claim that the weight loss is greater than 0. The mean weight loss is greater than 0. Okay, I'm going to solve one more problem, and then you're going to have examples to work on. So we're going to solve example 9.17. So problem 9.17 is on page 449. So let's see this problem. So we have here 9.17, and the problem says the following. So generic drugs are lower cost substitutes for brand name drugs. Before a generic drug can be sold in the United States, it must be tested and found to perform equivalently to the brand name product. The US FDA is now supervising the testing of a new generic and antifungal ointment. The brand name ointment is known to deliver a mean of 3.5 micrograms of active ingredient to each square centimeter of skin. As part of the testing, 7 subjects apply the ointment. 6 hours later, the amount of drug that has been absorbed into the skin is measured. The amounts in micrograms are 2.6, 3.2, and so on. How strong is the evidence that the mean amount absorbed differs from 3.5 micrograms? I'm going to use the alpha equals 0.01 level of significance. So now alpha is different from before. So let's work on this problem now. So let's see what happens with this information. So we're going to need to write our claim and everything. So let's see. Let's see. Let me just switch to another. Okay. So in this problem, we're gonna have to work first the claim. So the claim is that the mean amount that is absorbed differs from 3.5 micrograms. So the opposite is just mu equals 3.5. Then the alternative is going to be the one that doesn't contain the equal sign. So the alternative is just mu different from 3.5. The null is the one that contains the equal sign. So from here you're going to see that this is a two-tailed test. A two-tailed test, and we're going to need to check whether the normality is in place for this data set. And if that's the case, we know that we're dealing with the mean. We don't know the standard deviation of the population, so we're going to use the student t distribution as our sampling distribution. This is going to be our sampling distribution. So we're going to find then the test statistic. Our test statistic that we need is the mean. So to find it, we need to enter the data set in R into our console. So we're going to enter the values 2.6, 3.2, 2.1, 3.0, 3.1, 2.9, and 3.7. So I'm going to do this in R, and then I'm going to compute the mean and the standard deviation, because this time is not given, so you need to get it. So x equals c, 2.6, 3.2, 2.1, 3.0, 3.1, 2.9, and 3.7. So that's, then you can create a histogram and see whether there is normality. It looks like the sample shows some normality. You can also compute the QQ norm and QQ line of X. QQ norm. And let's see what happened here. So my window shows now that it's almost a line. It's a straight line here. So there is normality. So now we're going to need to compute the mean and the standard deviation of the sample. So that's the mean, and that's the standard deviation of the sample. So I'm going to write down these values. So normality was checked by using histogram of x or QQ norm of x. So we found normality, and the mean that we found is 2.9422, and the standard deviation 0.4995 to 36. So you're gonna see now the notes. So I have here the mean was obtained by using mean of x. The standard deviation was obtained by using SD of x. So those are the commands that I use to find these two values. So now we're gonna compute our test statistic. So our test statistic is just we need to compute t. So let's do that. So to compute t, we're gonna need our formula. So this is gonna be compute the test statistic t. So t is gonna be x bar minus mu from the null over s over the square root of n. So in our case, it's gonna be the mean that we found, 2.94, minus the mean from the null is 3.5, and we're gonna divide this by the standard deviation, 0.4995 to 36 over the square root of the number of data values, which is 7. So that's the computation that we need to perform to find t. So let's do it. So let's see what happens. So we're gonna go back to our R console. So I have now a parenthesis and 2.9428 57 minus 3.5 over the standard deviation divided by the square root of the number of data values, which is 7. So the t value that we find in this way is negative 2.95035. So that's the statistic, the test statistic. So now the next step is just compute the p-value to make a decision. So we're gonna make a decision by using the p-value method. So we know that this is a two-tailed test. This is a two-tailed test. So we have t here equals negative 2.95. So this and this are going to be used to get the p-value. So this is the p-value, and this is also the p-value. Both areas together are the p-value. So in this case, when your t is negative, you just need to use 2 times pt of t, degrees of freedom. So you're gonna have just a p-value is gonna be 2 times pt of negative 2.950935, and 7 minus 1 are the degrees of freedom. So let's see what is the value that we're gonna obtain by doing this. by using our console. So we're gonna get 2 times pt of negative 2.95 comma degrees of freedom 7 minus 1. So we're gonna get a p-value equals 0.02558191. So then you just need to compare this to alpha. So we need to check alpha. So the value for alpha, if you read the problem, now this time is 0.01. So we're gonna compare, and we're gonna see that the p-value is greater than alpha. So we cannot reject the null. So we're gonna say in our conclusion, we're gonna write that there is not enough evidence to reject the null. Now we see that the null is different with respect to the claim. So the claim and the null are different, so that means that we need to adjust our conclusion. We need to modify the wording. So we're going to write there is not enough evidence to accept the claim. The claim that in this case there is a difference in the treatment. There is not enough evidence to accept the claim that the generic drug is going to work as the brand name drug. You just copy that from the problem. So let's see. We're gonna now. So there is no difference. Okay. That the mean. Let me complete just that. That the mean amount of drug that is absorbed differs from 3.5 micrograms. So there is no difference. Okay. So you're gonna solve now problems from this section to end our work for today. So let's see, you're gonna work on what problems? I have here 2 problems for you. So you're gonna work on section 9.3 exercise set on page 457. You're gonna work problems 23 and 24. So work on these problems because you're gonna have problems like this in your quizzes online and in your final exam too. So let me project the problems for you to work on them. So problem 23 is here. So just copy your data set. So you're going to need to show that there is a normality. The condition of a normality is satisfied by using a histogram or QQ plot. And then you're going to conduct the hypothesis test that is indicated in part B. So that's for the first problem. For the second problem, you have another data set. You're going to need again to check normality by using a histogram or by using a QQ norm plot. And also, again, you are given a data set, so you need to compute your mean and your standard deviation for the sample, and then proceed and work on the hypothesis test that is described in part B. So with this, we finish 3 sections of chapter 9. In the next lecture, we're going to finish the chapter with by performing hypothesis testing on proportions and standard deviation. So work on your classwork and send me that by using Canvas and the submit button.